Okay, let's straight get on to the. So
I
I
have
would
a
like
question.
that you. Uh-huh.
So A is always the further side.
No, not necessarily. This is just to say that so MA, right? So अगर ये side का moment लेना है, so is
Oh
MA
yeah,
is
the side on
basically
that side.
W
Okay.
into A
Hmm.
into B squared by L squared. अगर MB लेना है तो W into B and दूर वाला A squared divided by L squared ऐसे.
Yeah. Thank you.
ठीक है, okay. So that was that. So what now we will do is straight away do a example so that yeah we will learn which formula what and all that to put. Um, let's do a simple one. Okay, this is let's say 60 kilonewton. Okay, and this is 12. This is let's say 6 meters. And this is A and this is B. Find out the maximum bending moment and the bending moment at the ends. Okay, so this is a very simple case, which is the first case here. And you know that MA and MB is equal to WL by 8, whereas maximum moment is also WL by 8. So basically, you just need to find out one value here. Yeah, so MA slash MB is equal to WL by 8. W is 60 kilonewton. Uh, let's keep kilonewton meters. So W is 60 kilonewton and L is 6 divided by 8. Right, so this will be 360 divided by 8. Um, so this will be basically 360 divided by 8, 45. 45 kilonewton meter. Now the final this is getting completed only after you make the BMD. So you need to just simply make the BMD. The BMD will show like this. And जहाँ पे the place of loading is, that's where your maximum bending moment is going to be. So this is how you will draw. Yeah. Okay. So this you have to show that this as positive and this as negative. It's not quite visible. Positive. Okay. So this is 45 and this is also 45 kilonewton meter. ठीक है, हो गया. This is as simple as it can get. Okay, so for the first situation is done. The second situation is what we will do now. Um, Second situation, consider the same beam. Yeah. किसी को कुछ पूछना है? ठीक है ना? It's just very simple. Consider the same beam. I'm just same beam in the sense it's like 6 meters. Yeah. This is small w is equal to 5 kilonewton per meter. Okay. So we know that this is what we are talking about, situation number 2 here. So MA or MB is equal to WL square by 12. So MA um, by MB is equal to small w L square by 12. W is equal to 5, so just 5 into L square is 6 squared, so 36 by 12. So ये 36 है, so basically 12 threes are, so this gives us 15 kilonewton meter. Okay, so this is what is MA or MB. Maximum bending moment. Maximum bending moment is going to occur at the center of the beam because it's uniformly distributed load, and which is WL square by 24. L square by 24, so basically this is going to be iska half, right? So which is 7.5. मैं तो लिख देती हूँ 5 into 6 squared divided by 24. So this is going to be 7.5 kilonewton meter. Okay. The final thing is to just draw. So if this is 15, so this has to be somewhere 7.5 and this will be 15. Okay. So I'm just drawing. So this is 7.5 kilonewton meter. This is positive and this is negative, which is 15. ठीक है, that is what it is, as simple as it can get. ठीक है, इतना सबको समझ में आया? अभी कुछ पूछना है किसी को? All is good so far? Yeah? No? Yes? No?
Yes.
Yes? Okay. What's up with everybody? Why is nobody talking today? Where's Shravan? Is Shravan around today?
I'm here. I still have to fully watch last time's not episode, recording because I missed it. So I'm kind of lost, but I'm getting the gist of it.
Okay. All right. Um, fine. Okay. Well, today आज तो कुछ ऐसे मजा नहीं आ रहा है. Nobody's talking. Nobody's saying anything. Okay. Barely there are like 60 people today. ठीक है. Anyhow, so what we'll do now is so quickly just move on to if जो भी ध्यान दे रहे, if they find it okay, then we'll quickly move to the next one. Have you noted these thingies down here? The formula, Fleur, Ambika.
I have a question again. So
Uh-huh.
it'll be only 15 kilonewton meter, not minus 15 kilonewton meter. Like we
No,
don't have
no,
to put a minus because it's in the
no.
okay.
हम already उसको minus में ही बना रहे हैं ना. We are drawing it like this.
So it's fine. Okay. Yeah.
Yeah. It's fine. Yeah. Okay. So now what we'll do is okay. Now let's do something that is eccentric, right? So यहाँ पे लेते हैं. Let's take a beam like this here. And let's put a load here. Let's say this is 15 kilonewton. And this is, I don't know, like 4. And this is 1. Okay. This is A and this is B. So now we need to find out what is MA, MB, and bending moment maximum. Bending moment maximum यहाँ पर कहाँ पे होगा bending moment maximum?
At A.
Maximum यहाँ पे होगा, यहाँ पर.
Yeah.
Okay. Why at A?
Because the load is like far apart from me.
So the load is far away from A. So वहाँ पे maximum होगा या ओके ठीक है बट ओके यहाँ पे फिक्स्ड एंड मोमेंट है ना देयर इज फिक्स्ड एंड मोमेंट हियर द मैक्सिमम सैगिंग मोमेंट कहाँ पे होगा
The load.
पॉजिटिव मोमेंट आई मीन
At where the load acts.
Towards B.
okay towards B and somebody said at the somebody
the
said
At,
something
at where the load acts. At 15 kilonewton.
yeah at where the load acts is where the maximum bending moment is going to be okay now so this is how we will draw ultimately the bending moment should look something like this the bending moment should look like that okay and this is what यहाँ पे this is where the load is right so the maximum bending moment is going to be here ये center पे हम draw करते हैं क्योंकि center पे load है in the previous example when we drew the bending moment for a single point load that was we drew in the center like a mountain only because it was where the load was acting so agar the load is acting eccentrically so the maximum bending moment is also going to be there only ठीक है so the basically now the thing is going to be this is the this is how the bending moment will look like okay so this is where the positive part is this is negative and this is negative we need to find out what is the value here and we need to find out what is the value here and here okay now let's find out the MA MA हमने बोला MA is equal to W MA. If this is A, so this is A and this is B distance, right? So MA मतलब ये वाला this is MA and this is MB. Okay. So MA is equal to WA into B squared जो further away है divided by L squared. ठीक है so W is कितना W is 15 into A is 4 into B is 1 so 1 squared divided by total length 4 plus 1 5 so 5 squared
Got 2.4.
कितना आया 2.4 okay so this is 2.4 kilonewton meter now what is MB MB is going to be W into B into A which is further away A square into L squared so this is going to be 15 into B is 1 and A is 4 so 4 squared divided by 5 squared okay how much is this one now
9.6.
कितना 9
9.6.
9.6 so this is 9.6 kilonewton meter okay kilonewton meter sorry okay now there is an interesting point here if this were we need to still find out what is the maximum point here okay so this point maximum bending moment okay maximum bending moment if it were a simple sa beam with a roller support और यहाँ पे होता अगर हाँ this is A distance and this is B distance and this is W Oh, sorry. Okay, if I have to draw the maximum bending moment, though, I will draw this sort of like a triangle. Okay, I'll draw like this. Okay, this is the positive one. अगर ये होता है तो now what I need to figure out is that ये जो यहाँ पर है इसका value क्या है? This value is W A B by L. आपको याद होगा अगर फर्स्ट सेमेस्टर का कोई नोट्स कुछ याद है तो ये हमने किया था W what is it WA into AB by L. Okay, so this is the, if this were a normal beam, then this is what is the value. Now if that is the value, so this number is going to be, let me just write here only, 15 into 4 into 1 divided by कितना है 5 ना 5. So this is 3s are 3 12. Okay, so this is 12 kilonewton meter. Okay, अभी इतना समझ में आया सबको? Any question so far? किसी को कुछ पूछना है?
No questions.
No questions? Okay. अभी एक इम्पॉर्टेंट चीज है कि ये जो हमने डायग्राम ड्रॉ की है ना, वो इसमें से ये इधर से लेके, लास्ट टाइम याद है हम लोग कर रहे थे नेगेटिव एरिया इज इक्वल टू पॉजिटिव एरिया करके, या तो आई एम जस्ट ड्रॉइंग दिस हियर एंड लेट मी जस्ट यूज अ डिफरेंट कलर. So I'm drawing the positive area. Okay, so positive area is like this. Positive area ये आया 12 kilonewton. अभी let me just draw the negative area. The negative area is एक ज़्यादा है और एक कम है, right? So I'm drawing on top of it. Okay, I'm overlaying it. So MA is 2.4 और MB is 9.6. Right? This is 2.4 and 9.6. So I'm just okay. So ये है 9.6 और ये है 2.4. All right. अभी so there is that whatever negative area. So all this area will get negated. So ultimately मुझे ये find out करना है यहाँ पे ये value कितना है. Okay. सबको समझ में आया what is the task at hand here?
Can you repeat like after the negative thing?
Yeah, okay. So what I did is that last time बताया था ना मैंने कि ये पूरा negative area है. Negative area and positive area को we have overlaid. So अभी क्या है, all this area will get cut. ये कट हो जाएगा, ये पूरा एरिया कट हो जाएगा. तो अल्टीमेटली दिस इज द डायग्राम व्हाट इज लेफ्ट. ठीक है, यहाँ पे तो हमको पता है दिस इज 9.6, बट हमको ये जो 12 है ना, ये 12 यहाँ से शुरू होता है, यही से इधर से लेके 12 इधर तक शुरू होता है. दिस मच इज 12. बट मुझे ये फाइंड आउट करना है इतना कितना है, ये एरिया कितना है, इतना, हाउ मच इज दिस मच. So how do I find out? इतना कितना है? How do I find that out? समझ में आया?
Yes.
So I'm just going to draw थोड़ा इसको fair करके, let me just draw. Okay, ये मेरा 2.4 है और ये मेरा 9.6 है. Okay, so this is 9.6 and this is मेरा 2.4 और मुझको ये फाइंड आउट करना है. दिस ये जो 12 है, लेकिन वो 12 क्या है? इट इज प्योर. इफ दिस बीम वर अ सिंपली सपोर्टेड बीम, देन अल्टीमेटली उसका W इंटू A इंटू B, दैट इज उसका पूरा प्योर बेंडिंग में जो आ रहा है, दैट इज व्हाट इज द वैल्यू हियर. सो 12 इज नथिंग बट व्हेन द बीम इज अ सिंपली सपोर्टेड बीम, तभी वो आता है. ठीक है, तो मुझे ये फाइंड आउट करना है कि इतना वैल्यू कितना है. ओके, सो ये 0 0 लाइन से इधर तक ऑन द टॉप इज 12, लेकिन यहाँ से मैंने ये एरिया पूरा नेगेट कर दिया ना, ये पूरा खाली हो गया, कट हो गया, ये पूरा कट हो गया और इतना ही बचा है. ठीक है, आई मे बी इरेज इट. फ्लर समझ में आया?
Yes, yes.
So how do you think you will be able to find out what is the value here?
By plotting it on a graph.
Plotting on the graph. Do you really need to plot it on the graph?
It would be super easy if we did.
Well, if the yeah, but let's say if your beam is 12 meters, what do you? Well, yeah, well you can understand the same thing by using the funda, right? तो यहाँ पे तुमको पता है दिस इज अ स्लोपिंग लाइन, राइट? ये 2.4 से 9.6 तक जा रहा है. So you know that for a beam of 5 meters, it is going from 2.4 all the way to 9.6, right? Yeah, so अगर let's say 9.6 minus 2.4 किया अगर, तो 7.2 आता है. ठीक है, so is equal to 7.2. So right from ये zero से the value is increasing 7.2, right? तो अगर 5 meters के लिए 7.2 increase हो रहा है, तो 4 meters के लिए कितना increase होगा? Can I find out? So होगा 4 into 7.2 divided by 5.
5.76.
5.76, right? So this is equal to 5.76. ठीक है ना? इतना तो ठीक लग रहा है ना? So मतलब उसका मतलब क्या हुआ कि 5.76 इंक्रीज हो रहा है. ठीक है, सो 5.76 प्लस 2.4, क्योंकि हमने 2.4 नहीं ऐड किया था ना, तो दिस डिस्टेंस इज गोइंग टू बी कितना?
Can you explain the last part again? Sorry. The 5 to 2. Yeah.
Yeah,
I
so
got it 7.2 and then I didn't get the equation that we did.
हाँ, मैंने इसको जीरो लाइन कर दिया. ये 2.4 को फ्रॉम हियर आई एम ट्राइंग टू सी कितना इंक्रीज हुआ. ओके, सो ये मैंने इधर से ऐसे कर दिया. सो ये you know I have made it like this. So for a distance of 5 meters, it is increasing 7.2. हाँ, क्योंकि इसके नीचे क्या है? 2.4 है, और ये पूरा इधर मैंने अगर किया ये, तो ये पूरा इज 9.6. ओके, नाउ आई फिगर्ड अगर ये जीरो है, अगर मैंने यहाँ से शुरू किया तो ये लाइन जीरो है. जीरो से व्हेन आई एम गोइंग 4 meters, I am getting that this value is 5.6, 5.76, sorry. राइट? तो इधर से लेके इधर तक has to be 5.76 plus 2.4.
Yeah.
फ्लोर, ठीक है?
Yeah.
Yeah, 2.4 plus 5.76 gives me 8 point something, 8.16, right? So this entire distance is going to be, let me just write here, 8.16, right? अभी इतना डिस्टेंस, मतलब ये जो डिस्टेंस है वो इधर से लेके इधर तक 8.16 है. I'm actually interested to find out only this much distance, right? So I might as well
3.8.
just minus 12 out of it. So I get 3.84, right? So this is 3.84. Bouncer gaya.
I didn't understand.
Huh. So how much did you understand? Tell me that. So I can start from there.
Okay, I'm sorry, but after you did the 5 arrow 2.4 arrow 9.6 niche, from there I just
Uh-huh.
very confused.
ठीक है, okay. So you, I will draw this diagram once again here, okay? So we figured that we have to overlay these, overlay किया, उतना तो समझ में आया ना?
Huh, the positive and the negative, and then you negate
हाँ,
it.
so yeah, so this is what we did with the positive wala, and this is what I'm doing with the negative wala part, okay? So ये ऐसे जाके इतना हुआ, okay? So now we know some values. We know the values. We know the values. यहाँ पे the value is 12. The value here is 9.6, and the value here is 2.4. ये वैल्यू करेक्ट है, ये वैल्यू भी जैसे चाहिए वैसे है. आई एम इंटरेस्टेड इन दिस स्पेसिफिक वैल्यू बिकॉज अल्टीमेटली आई ओनली एम इंटरेस्टेड इन दिस काइंड ऑफ लाइक अ डायग्राम ना, यहाँ पे जैसे ये बनाया है, या this diagram is where I am interested in, correct? This wala. I'm only interested in this one. I'm not interested in either. So I am interested in this value. ठीक है अंबिका?
Yeah,
ठीक है?
huh.
तो ये this is the value I am trying to seek. Now I know that this green वाला line is a sloping line. ठीक है? ये धीरे से slope increase हो रहा है. So from 2.4 it is getting increased to 9.6. So for every 1 meter how much is it increasing is what I am trying to find out. ठीक है? So 2.4 minus 9.6 gives me 7.2. So from wherever it is increasing 7.2 from wherever it is, like, so this is 0 meters all the way to 5 meters, यहाँ तक it is increasing 7.2, right? इतना ठीक है ना?
Huh.
So from here 2.4 हाइट है इसका, लेकिन वो इंक्रीज भी हो रहा है वर्टिकली 7.2. ऑल राइट, सो अभी 5 मीटर्स के लिए 7.2 इंक्रीज हो रहा है. तो मुझे ये पता करना है, क्योंकि ये वाला जो लाइन है, ये लाइन 4 मीटर्स पे है, तो 4 मीटर्स पे कितना इंक्रीज हुआ? तो 4 मीटर्स पे इंक्रीज हुआ 5.6, 5.76. ओके, सो ये 5. मतलब ये लाइन यहाँ से this line here is 5.76.
Rajada, how did you get that formula for 4
Which
meters?
formula?
The
Which
the
formula?
second.
ये वाला?
Yeah, how did you get the formula?
It's very simple ना, see. अगर ये इतना increase हो रहा है और यहाँ पे let's say 0 है, it's a steady increase, right? अगर ये 0 है और it is increasing to 5, हाँ, on a distance of 5 meters, I'm only trying to figure out every 1 meter पे कितना increase हो रहा है. So I know that for every 1 meter, it is going to increase 1 meter, 1 meter, 1 meter, 1 meter. So if I want to know 3 meters में कितना increase हुआ, तो that I can find out, right? So from 0 से 5 meter तक 5 meters increase हुआ, right? So 5 meters के लिए there is a 5 meter increase which is increasing. So if I want to know 3 meter पे कितना increase हुआ, so this is going to be 3 multiplied by 5 and divided by 5, right? So this is going to give me 3 meters, right? So this is 3 meters.
All right, got it.
Got it? Okay, so this is 3 meters, right? So this is exactly what I am doing now here. So I figured कि ये पूरा कैलकुलेशन करके मुझे 5.76 मिल रहा है, लेकिन 5.76 इतना डिस्टेंस हुआ, मैंने 2.4 मुझको ऐड करना है ना, तो मैंने यहाँ पे नीचे 2.4 भी ऐड कर दिया. अगर 2.4 ऐड किया 5.76 में, आई एम गेटिंग 8.16. All right, so that means that this entire distance is 8.16. Okay, I'm interested in this छोटू सा thing. So ये 12 है, इधर से लेके नीचे तक 12 है, और ये 8.16 ये green line से black line तक है. So I'm 12 minus 8.6 किया, तो I get finally 3.84, ये वाला नंबर. ठीक है?
Understood. Yeah. Thank you.
पक्का पक्का पक्का.
पक्का पक्का.
ओके. किसी और को नहीं समझ में आया तो पूछो. Everybody else is just hanging in there. पूछ लो, फिर बाद में समझ में नहीं आएगा तो you will not be able to figure out कैसे निकाला एक्सेट्रा एक्सेट्रा. ठीक है, तो इसमें कुछ नहीं है, ये खाली स्लोप है, थोड़ा सा कंफ्यूजिंग है, दैट्स ऑल. इसमें ऐसा कोई दूसरा ये नहीं है. ओके, so this is how you will do. So this is ultimately the bending moment diagram that we want. Okay, this is the final bending moment diagram we need. ओके, कैलकुलेशन वगैरह कर लिया वो तो ठीक है, लेकिन बेंडिंग मोमेंट डायग्राम नहीं होगा तो मार्क्स नहीं मिलेंगे. ठीक है, तो बेंडिंग मोमेंट डायग्राम इज वेरी वेरी नेसेसरी. ठीक है, ये हो गया. सो वी डिड नाउ विथ eccentric loading, we did with what to say, middle wala loading, and UDL also we did. Now let's say you have two loads. Okay, let's say you have two loads, तो कैसे? With two loads, I think let's try and do two kind of situations. Let's try and figure out if both the loads are same and both the loads are different. ठीक है, तो यहाँ पे करते हैं, let's put like 60 kilonewton and यहाँ पे भी 60 kilonewton. ठीक है, this is 3, this is 2 meters and this is 3 meters. Yeah, it's all kind of like equidistant. Let's try to find out what is MA, what is MB, and what is the maximum, and what is the final BMD. All right. So, okay, any idea how to approach this problem? Any idea? कोई भी guess मारना है तुम्हारो? Any guesses?
2 parts में solve.
ओके करेक्ट. 2 पार्ट्स में कौन से 2 पार्ट्स में? कौन से
Like
2
पहले
पार्ट?
first 60 वाला load 3 and 2 and then 2 and 3 with 60 वाला. I don't know.
अच्छा, यू मीन टू से दैट हम ये 2 लोड है उसको एक एक करके लें?
Probably.
ओके. हाँ चलो वो भी कर सकते हैं. एक्चुअली दैट वे आल्सो कैन बी डन. और कोई तरीका है?
Maybe using the thing that we learned in first year, like at every point the distance multiplying by the load.
ओके.
And clockwise and clockwise, I'm not sure.
हाँ, okay. So let's first of all go back to the last week thing, which says that total the area of sagging, right? Area of sagging, or let's write area of positive moment has to be equal to area of negative moment, right? Negative moment, पॉजिटिव मोमेंट एंड नेगेटिव मोमेंट. तो हमको ये फाइंड आउट करना है कि अल्टीमेटली जितना भी पॉजिटिव मोमेंट आ रहा है और जितना भी नेगेटिव मोमेंट आ रहा है वो दोनों का हमको ये पता है कि उसका एरिया वॉट एवर इज द टोटल क्वांटम, दैट क्वांटम इज गोइंग टू बी इक्वल टू ईच अदर, राइट? अदरवाइज उसका स्टेट ऑफ इक्विलिब्रियम कैसे मेंटेन होगा, राइट? सो क्या करते हैं ना, द जैसे तुमने बताया वो तरीके से भी कर सकते हैं. But the most easiest way of doing is if you do it and figure out like this. Okay, this is a simply supported beam. So let's split this as a simply supported beam and a beam with a simply supported beam with this load 60 or 60, and let's assume so this is equal to this beam plus this beam where जहाँ पे आपने negative moment induce किया है. Okay, this is the negative moment. So if this is A, so this is MA and this is MB. All right. तो इसका बेंडिंग मोमेंट कैसे होगा? ड्रॉ करेंगे अगर तो इसका बेंडिंग मोमेंट कैसे होगा? ये सैगिंग है ना, सिंपली सपोर्टेड बीम है, ऊपर से दो ऐसा स्टील का रूलर लिया अपने हाथ में, दोनों फिंगर्स पे सपोर्ट किया है और ऊपर दो लोड है. दैट लेट्स से यू पुट टू glasses or something. The way it is going to sag is it is going to sag like this, right? Right. तो इसका बेंडिंग मोमेंट का डायग्राम इज गोइंग टू लुक लाइक दिस. या इट इज यहाँ से 0 है क्योंकि हिंज सपोर्ट है तो मोमेंट तो 0 है. फिर जैसे 60 किलो न्यूटन पे पहुंचेगा वो स्टडी हो जाएगा ना. उसके आगे कोई भी लोड नहीं है तो जितना भी लोड है जहाँ पे भी है वहीं पे है. उसके बाद में 60 किलो न्यूटन है, उसके बाद में 0. ओके, so this is how this is the positive thing. Or because it is because both the loads are same to each other, what will happen, उनका जो भी negative moment है, that negative moment is also going to be the same, right? So I'm just, the negative moment is also going to be same. Okay, I should have drawn. This is 0 0 line के नीचे draw कर रही हूँ. Okay, so this is negative moment. Now if I put this on top of this, then I will have, I'm just simply putting this on top of this. Okay, so ऐसे होगा अगर, तो मेरा ultimately my bending moment is going to look like something like this. ऐसा है, ऐसे, ये प्लस है और ये माइनस है और ये भी माइनस है. ठीक है, बिफोर वी अटेम्प्ट टू टेक अ क्रैक एट द थिंग, इफ वी कैन रफली रिजॉल्व द बेंडिंग मोमेंट डायग्राम इन आवर माइंड, आई थिंक इट ग्रेटली हेल्प्स कि which values we have to find, and it will define the course of how to find or how to do the exercise also. ठीक है, ओके. नाउ फर्स्ट सेमेस्टर में जैसे किया था वैसे कर सकते हैं. एम ए और सिग्मा एम ए इज इक्वल टू, ये बीम पे अगर देखें और सोचे कि दिस इज 60 और ये भी 60 है और उसका हमको एम ए फाइंड करना है, तो एम ए इज इक्वल टू 60 किलो न्यूटन इंटू क्या बोलते हैं ये 3, राइट. 3 प्लस what is this, 60 kilonewton again, 60 kilonewton into 5, and reaction भी 60 है, so minus 60 into how much is that going to be, 8. Okay, is equal to oi, I did gadbad, I shouldn't have done that this way. MA though is always going to be 0 only. Let me write here 60. This, we will do this only when we have to find out what is the reaction, but we can guess that the reaction is 60 and 60 because it's equidistant and the thing is okay. So we will do this if we needed to find out what is RB. Okay, therefore we can say that RB is equal to 60 and therefore RA is equal to 60. Okay, इतना समझ में आया ना what we are doing? Any question, anything कि कुछ समझ में नहीं आ रहा है? Yes, no, yes, no. Okay, anyway.
Yeah,
Okay. Yeah, okay. So now we have to find out what is this point pay load. Oh, sorry, what is this point pay bending moment? Okay. So I'm going to find out the bending moment at this point. Bending moment at that point is going to be what? So we take care of only one side of the beam, right? So we divide the beam at that point and we figure out, okay, VA, or sorry, RA into 3 is equal to the total moment that is happening here. So let's say this is X and this is Y, and that is equal to mx. Okay, so RA, since RA is 60, so 60 into 3, 180 kilonewton meter is equal to mx, right? So since there is symmetry here, we can also say that mx is equal to my. Okay, so we can say that this is 180. So this is also 180. Okay. Now the interesting thing now to find is what is MA here, or let's say this, let's write MB and this is MA. Okay. Now this one, this is 180 and this is 180. Now this is positive, right? So this area has to be equal to this area, isn't it? So we can write that ये जो area है total, if I take the total area of this one, has to be equal to this total area, right? So what is the area? So I'm just writing area of positive moment is equal to area of negative moment. Negative moment is ma into L. ये rectangle है इसीलिए ma into L and this is trapezoid, right? So trapezoid के लिए what I'm just simply doing is that it is 180 into what is the total length? 8 plus 2 divided by 2. Okay, so 180 into 5. So 180 into 5 divided by 8. So MA is equal to 112.5 is MA. Okay, you guys are lost.
Can you please explain from RA into 3 is MX? Sorry.
Which one?
I got it till MA is 60 into 3 plus 60 into 5 minus RB into 8.
ये वाला.
And then, yeah, after that I kind of got lost.
अच्छा,
Like,
okay. MA is equal to okay. So before we find out these things, we need to find out the reactions, right? Reactions क्योंकि यहाँ पे ऊपर 60 and 60 है, so the reactions are 60 here and 60 here, right? Correct?
yeah.
Okay. Now if we didn't know that, let's say 60 की जगह पे एक 180 है और एक 60 है, so we would have to use this equation because that is the way how we'll ultimately find out what is RB. So we know that M, because it's a hinge joint, summation of all the moments at support A is going to be 0 because it is a hinge moment, hinge joint, right? So 60 into 3 plus
Yeah.
this 60 into 5 minus this 60 into 8, right? So this is minus, so minus RB, right? RB अपने को पता नहीं. Let's say if it is 180 and some other random number, so we wouldn't know that, so we will use minus RB into 8, and that is the way how I will be able to find out what is RA and RB. Correct? So अभी क्योंकि यहाँ पे the total load that is acting on the beam is symmetrical, it is equal to each other. I know very clearly that this is going to